Hello, let's go ahead and look at section 9.2, one-sided limits and continuity. So a lot will be going on in this section. Go ahead and take a moment to read through this notation and try to understand what the heck it's talking about. And then I will explain by way of example. What you really want to understand here, what you really want to home in on is right here. This plus symbol in the superscript position of base A. So the limit of the function f of x as x approaches a from the right. So this is only looking at the limit of a function as x approaches a from the right. And if you're able to come up with some real defined y value, then that y value would be equal to whatever it is. Okay? So let's take a look at a couple of examples. In the first two examples, we're going to look at the table method again, because if you look at these two, there's nothing really you can factor and reduce. So in letter A, let's go ahead and set up a table. And we're coming from the right here. You got to recognize that. We're only looking at this limit as x approaches 1 from the right. And again, if you just were to plug in a 1 right now, you'd get a 2 over 0 situation, which would be undefined. So let's see what happens when we set up our table. So we're coming from the right. Here's the right side. Our table does not need to be as large as the ones we used in section 9.1, because in section 9.1 we were coming from both ways. Now we're just coming from the right. So let's go ahead and put a 1 here, and we'll make a note that this is indeed undefined when x is 1, because you get 0 down here, undefined for the function f. And then we have to make 3 columns here. Again, use base 10. So we're going to go a 1/10 of a unit away, a 100th of a unit away, and a 1,000th of a unit away. Exactly the same thing we did in section 9.1 using the table method, except now all we have to do is look at it coming from the right because of this plus symbol in the superscript position. Okay? So this would be a 1/10 greater than 1, 1.1. And then as we move from right to left, moving this way, this would be 1.01, and this would be a 1,000th of a unit away, real close to 1, would be 1.001. And then you can use your calculator if you like, plug in each of these 3 values into the function, and see what you get for f of x. So if you replace the 2 x's with 1.1 here, you get negative 21 for y, or f of x. If you replace both these x's with 1.01, you get negative 201. And finally, if you were to replace both x's with this value, you get negative 2001. Well, as you can see, these values are getting smaller and smaller and smaller. The y values are getting smaller and smaller and smaller. They're not homing in on or approaching one specific y value. Therefore, this is actually approaching negative infinity, but because it's approaching either infinity or negative infinity, we say that this limit does not exist. If you ever have a limit that is approaching infinity or negative infinity, really that implies the limit does not exist. Okay, let's take a look at letter B. So again, nothing we can do here. Let's go ahead and set up our table, and we are again approaching from the right. So if we were to put in a 2 in this situation, we get 2 minus 2 under the radical, which is 0. Square root of 0 is 0, and 0 times 2 is, guess what? 0. So we do get a defined answer there. But here's the thing. We have to make sure that this function is defined as we approach from the right. We have to make sure that the y values are equal to something as we approach from the right. So let's use our base 10 again. So 2.1, getting closer, 2.01, getting real close now, 1,000th of a unit away, 2.001. If you were to replace the x here with these 3 values and get defined y outputs, which we are getting here, then yes, the limit will be equal to 0. And so I'm plugging in these values into this x, and I'm getting nice, real output values for y. And so because that's the case, because it does exist here as you approach from the right, the limit of this particular function as x approaches 2 from the right is 0. Now we're going to look at really the exact same concept except coming now from the other direction. So as x approaches a from the left. And you know it's going to be approaching from the left if there is a negative symbol here in the superscript position, okay? So this is read the limit of the function f as x approaches a from the left. And if you're able to home in on a real y value, then that'd be the answer to the limit. So let's look at a couple more examples. All right. So letter A. Well, again, we can set up a table here and just see what's going on with this particular function. And I'm setting up a table because I can't factor and reduce anything here, right? So let's see, I have my x here, I have my f of x here. And we're approaching from the left this time, so that's going to be coming from the left this way. So I'm going to go ahead and put my -3 here for x, -3 in there for x, and I do get the square root of 0, right? And so seemingly the answer, just by looking at it very quick, it might be 0. But let's see what happens though. We're approaching -3 from the left. All right, so let's make our 3 columns here. So from the left, this would be what? -3.1, -3.01, and -3.001. Okay? So let's see. If you were to replace this x with a -3.1, ooh, you get a -0.1. Do you see that? You cannot take the square root of a negative value and get a real defined result. So this is not exist. This is not real or undefined, okay? It's not real or undefined. I'm just going to put undefined to be consistent, all right? In fact, all of these will be undefined. It's really not real. You can't take the square root of a negative and get a real value. So because this function, in other words, does not exist to the left of -3, there's nothing graphically on our coordinate plane system to the left of -3. This function does not exist. The limit of this function as x approaches -3 from the left does not exist. The only way something like this, which is a radical function, will exist when you're approaching from one direction or the other is if it's defined everywhere coming from the direction indicated, okay? And here it's not defined. Therefore, the answer is DNE. The limit here does not exist. Let's look at letter B. So letter B, the first thing you might be thinking is, well, can I factor and reduce this? Because you can always factor and reduce regardless of how you are approaching the x value. So you're thinking that, however, this is not factorable, okay? There's a +3 here. There's no way to factor this quadratic expression into the product of two binomials. So let's just try something else. Let's just try direct substitution. So if you were to replace every x with a 2, all right, regardless of how it is approaching 2, in this case from the left, if you can replace every x with a 2 and get a real and defined answer, then that's going to be our limit. And so if we do that here, we get what? We get 2 on top, or excuse me, we get 3 on top, right? 2 plus 1 is 3. And on the bottom, we get 4 minus 4, which is 0, plus 3, which is 3. So if we were to replace every x with a 2 here, we would get a 3/3 situation, which reduces to 1, and that is, in fact, the limit. Now, this is, easier, I guess, said than done for some folks because of, I guess, experience. See, this one is a rational function, whereas this one is a radical function. This one is going to exist as you approach 2 from the right and from the left. Okay, it's going to exist because of the type of function it is. It's a rational function. This one, being a radical function, is only going to exist on one side of this number. All right? It's going to exist this way, but it's not going to exist this way. Using your graphing calculator can help you to see if the function does exist or not.